See what you're becoming. Okay. We are live. Should have bought more coffee. That's fine for now. Okay. Guess. Hey, anybody's watching? Welcome to a nice Sunday stream. Good tune, that one. Okay, where was I? Oh, sure. Oh yeah. Okay, remember a little bit. Do remember being stuck. That's the last thing I remember. But I guess. Well, I was supposed to. Well, I thought I would. What's the word? Try and work on. Hang on. Yeah. Thought I would like do some research yesterday. But obviously I didn't. Got caught up with. What did I get caught up with? Oh yeah, I was upgrading some dependencies. It took all day, but it's done. Quite satisfying actually. Yeah, okay. So now gotta get this ESP to work. You know, when I look at the display and the ESP, I mean, you can see that it's like a lot more complicated. Well, not that much. Maybe it's just the chip, the ESP-82 something. Okay, so my plan here is, well, semblance of a plan is, well, I'm gonna ask the AI how to get unstuck. Unstuck. Surprisingly hard word. Unstuck. Funny. Okay. Alright, what do I need to know? Okay. What do I have? I have an ESP. Maybe I can just unplug it. Okay. ESP-01S Wi-Fi device. I'd like to write a simple driver for it. The datasheet has not been very useful so far. I just realized there's the actual Wi-Fi device, and then there's the ESP. It's hard to read. This one, yeah, okay. There's that chip. Don't really. That's not the chip I'm trying to program. It's the Wi-Fi device sensor or something on it. So I'm wondering if I should like pick my battles. I don't know. As maybe I can pass it the technical reference. Can I attach stuff here? Can you have a look? The reference and point me to the right direction. Oh, try again. Maybe I can try. It was 2 point. Really? You can use 4.5? Oh, okay. No. You need an API key. Makes sense. Yeah, this one. Spin that. Don't want that one. This one. Okay. Can I do? That's actually really cool. I didn't expect it to work. I would say, well, Theo and team are really good at what they do. Come on, Gemini. You can do it. Oh, it's a big document. Probably why. Okay. Okay. Here we go. Okay, that's good. Yes. Yeah, I think that I understood that bit. Yeah. AT command firmware. I do remember seeing this. What was AT? Can't remember. AT2. Jeez. Cat's complaining. Of course he is. The fuck? Shut up. Okay. AT command firmware. The most common scenario from another microcontroller. Yes. Yeah. Yeah. Do I use the UART serial connection? Okay, let me read through this a bit. If this is your goal, using AT commands via UART here, it's how the technical reference helps. Chapter 11. Let's go. 9, 10, 11. Okay. Let me go back. Oh, I can't. Top index. PWM. I2S. I2C. I mean, I guess I could use the UART, especially if there's documentation for it. Okay, it's a good start. Section 11.1. Okay, you can read this. Yeah. Okay. The AT command set describes the hardware, not the specific AT commands. AT. What is AT? Blah 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 blah. And that the firmware responds to. You need to find. Yeah. I have found it. Command set. Let's go. So, okay, that's actually pretty good. I was in the right direction. It's a good first step. Find, yeah, I have. Describes the chip pins module you need to separate. I do. I mean, it's labeled. Yeah. Let me check pin diagram. Okay. Yeah. Ah. Okay. Actually, that kind of makes sense. So, fuck. Almost dropped it. So if I, jeez, can't see it. Connects to 17. The RX. But the RX is here. '16 is TX. So I don't know if you can see this, but hang on. So you see here, like there. On this board, I think it's not connected correctly. I think I might just use a breadboard. Yeah. Yeah. So I need 8 wires and 20 resistors. Good question. What if I connected the other way around? Yeah, then RX and oops, sorry. TX. Yeah. But then why would you mix it up? Hmm? Hmm? Mm-hmm. Mm, well, I would guess I don't need a resistor. Conveniently. Hang on. What are the other pins? RST. Where does that go? Oh, it's not connected. Okay. Oh, okay. So there's only four pins connected. That's not too hard. $17 is, yeah, it's definitely the wrong way around. Although I can turn it, then it still kind of works, I guess. Oh, but I can't push it all the way down. What is 20? Oh, okay. I have buttons for those. Actually, how much does this matter? Because do remember, okay, okay, I'll come back to this. RX, no, UART and UART TX interchangeable. Can I specify them here? What is it called? Via software. Example, use GPIO 16 as TX and 017 as RX. Raspberry Pi Pico. Okay, while it thinks. Oops, sorry. Okay, steps for writing. Yeah, I don't know about this. Oh, so that's how it's supposed to be connected? TX is connected to RX? Oh. Why? Actually, you don't need to answer that. Okay. Something I don't understand fundamentally. Why is TX connected to MCU's RX and vice versa? Okay, so that's good. I can use the board. Doesn't have wires, so it's a bit more cleaner. I've already got enough wires on my desk. Oof, cold. Oh, you're answering the wrong one. Okay. It's just basic questions. Just calm down. Okay. On a dedicated hardware, no. Transmission. Ah, fuck. Okay, that makes sense. Hey, I learned something. So I think TX is transmit, RX is receive. So obviously, if one is sending, the other one has to receive. Okay. Yeah. Now I feel. Hey, that's pretty good. I learned something. Okay, I don't need to know the rest. I got it. I understand now. I thought the manufacturers got it wrong, obviously. Turns out I was the wrong one. Okay. Ooh, server is unhealthy. Is my Discord still open? Yeah. Probably not better not to switch to it. Don't want to be leaking anything. Server is unhealthy. Fine, nothing you need to know. That's fine. Right, okay. Excuse me. You need to find. Okay. Pins through module. You need a separate pinout diagram. ESP-01S pin out. Dia. Okay, it's got two LEDs. So I only see. Okay, I think there's one on each side. Okay. Power com TX. Oh, okay, so this is for SPI. That's why only the RX and TX are connected. And there's a. Okay, that's 3 volt. Ground. VCC, blah. Okay. Lonely binary. Now I'm curious. Okay, it's a shop. ESP-30. Okay, can't get distracted. Where was I? Okay. Steps for writing a simple 80 command driver. Let's go. Connect ground, it's all done. Find document. Okay. Great set of instructions. Host UART peripheral to match firmware. Okay. Ah, okay. I didn't know about that. Probably might be in the AT commands. Yeah, I'm feeling much better. Feel like all of a sudden this is doable. Nice. To be fair, I did think it was even possible for me. I mean, I know it's possible because we use Wi-Fi. Okay. Settings mean, but implement them. Okay. Right. Send commands. Ooh, okay. We need, it's like HTTP. It's HTTP. Receive response. Okay. Error. IPD. Okay, I think this could work. Thanks, Gemini. You have been helpful. Okay. How big is this chapter? 3, 8. Some crazy looking. Damn. It's like all sorts of colors. Yeah, it's not bad. It's like 5-6 pages. Okay. UART. Don't need that. Okay. So there's one more thing I wanted to check. Source code. Code core. No. How do I use? I just read it from the pin. Hang on. Yeah. Not needed. Actually, let me get this. Time 2040.I2C. Let's see what else. They have UART. Oh, they do. Okay, so that means, so if I do this, okay, it's pretty good. How? Config, import config. Where is it importing it from? Okay, never mind. Never mind. Okay. Register GPIO. 16. Sixteen is wrong page. 16 to transmit TX, and then 17 to receive. Yeah. Okay. And okay. Should I do that now? UART microsig. Unified abstraction layer. What is UART? It's a good question. What is UART? Synchronous. Oh, cool. Okay. That does make a lot more sense now. It's a cool website. Analog.com. Okay. Okay. Can take a slight detour because I think I don't understand this. Might not understand the commands. I do like a good side mission. Well, to be fair, it's what made this best in the first place. Transmitter. Okay. It's not that big. It's fine. Or a universal asynchronous receiver transmitter. One of the most used device-to-device communication protocols. That makes a lot more sense too, because we're receiving from another microcontroller, the ESP, blah blah blah. This article shows how to use hardware exactly. That's what I need to know. And properly configured, UART can work with many different types of serial protocols that involve transmitting and receiving serial data. Perfect. In serial communication, data is transferred bit by bit using a single line or wire. In a two-way communication, you use two wires. Successful serial data transfer. Depending on the application and system requirements, serial communication needs less circuitry and wires, which reduces the cost of implementation. Brilliant. In this article, we discuss fundamental principles using UART. Okay, hang on. Just gotta do one thing. I'm gonna go here. Yeah. Then edit stream info. actually. Making progress with ESP-01S to arrival. Do I care about the days? Not really. Site, new site, mission unlocked. UART. Okay, that'll do. Let's go. That's pretty cool. Okay. Back. Okay, and this, yeah, that makes a lot more sense. Okay. Yeah, we focus on packet transmission, standard frame protocol. Ooh, exciting stuff. Customized frame protocols that are value added features for security. Don't care. Or maybe it's the Wi-Fi driver. Yeah, but nobody's gonna use it. Hopefully. Especially during code development. During product development, this document also aims to share some basic steps and checking on a datasheet for actual usage. Okay. Maximize capabilities or an application. Let's go. The single biggest problem in communication is the illusion that it has taken place. Wise words, Mr. Shaw. Communication protocol plays a big role in organizing communication between devices. It is designed in different ways based on system requirements, and these protocols have specific rule agreed upon between devices. Okay, perfect. Embedded systems and computers mostly use UART as a form of device-to-device hardware. So there was something on my t-shirt. Hardware communication protocol. Among the mosquito. Should stop getting distracted so easily. Among the available communication protocols, UART uses only 2 wires for its transmitting and receiving ends. Okay. Despite being widely used method, it's not fully optimized all the time. Proper implementation of frame protocol is commonly disregarded using the UART module inside the microcontroller. Don't know about this frame protocol. Might not optimize it either. Quite loud. Okay. By definition, UART is a hardware communication protocol that uses asynchronous serial communication with configurable speed. Synchronous means there is no clock signal to synchronize the output bits from the transmitting device, unlike I2C. Going to the receiving end. So I'm curious now. How do they achieve synchronization? The two signals of each UART device are named transmitter, receiver. Okay. Now I know why it's flipped. Perfect. The main purpose of a transmitter and receiver line for each device is to transmit and receive serial data. I assumed. The transmitting UART is connected to controlling data bus that sends data in parallel form. What does that mean? Sends data in parallel form. Okay, the transmitting UART is connected to the controlling data bus that sends data in parallel form. From this, the data will now be transmitted on the transmission line serially bit by bit to the receiving UART. This in turn will convert the serial data into parallel for the receiving device. So there's a data bus here, there's a data bus here. Okay. And okay, you receive them in the same order. Take note that a UART device. Okay, so these are dedicated, so you can't, not interchangeable. Gotcha. For UART and most serial communication, the baud rates. Okay, gotta make a note of this. Set baud rate. Where was I? The baud rate. What is the baud rate? Baud rate. Number of signal changes or symbols transmitted per second. Okay. Modulation rate. Okay. Excuse me. Okay. It has to be same on both devices. Makes sense? Okay, there was a definition right here. Sometimes the baud rate is the rate at which information is transferred to a communication channel here. In the serial port context, the set baud rate will serve as the maximum number of bits per second to be transferred. Table 1 summarizes what we must know about UART. Method of transmission, asynchronous. Maximum number of masters, 1. Maximum number of slaves, 1. This is the Pico, and this is the ESP-0. It's a bit of a mouthful. BSP. From here on, referred to as ESP. Right. And speed. I did see this number somewhere. Okay. I'll come back to it. Getting a bit excited now. No. Okay, good. The UART interface does not use a clock. Okay, this one I'm curious about. It transmits data asynchronously. Instead of a clock signal, the transmitter generates a bit stream based on its clock signal, while the receiver is using a bit too loud. Well, what is a cat? Hang on, I'll be right back. Gonna get some coffee and gonna shut my cat up by feeding it, of course. BRB. Yo, hang on. Sorry about that. I am back. Let's see. Okay. Okay. Where was I? Hot. Okay, yeah. So doesn't use a clock signal to synchronize the transmitter and receiver devices. It transmits data asynchronously. Instead of a clock signal, the transmitter generates a bit stream based on its clock signal, while the receiver is using its internal clock signal to sample the incoming data. Go read that again. The transmitter generates a bit stream based on its clock signal, while the receiver is using its internal clock signal to sample the incoming device. Okay. Sounds good. Don't know what sampling means here. Sus the AI. What does sampling mean in this scenario? I was thinking, I think maybe it was a few days ago, that the AI has a great excuse for latency. Like if it takes too long, oh, it's thinking. So yeah, that's the greatest excuse for latency. Well, high latency. Okay. Sampling refers to the action the receiver takes to check the voltage level of the incoming data line at specific moments in time determined by its own internal clock. Damn. Ah, okay. So you look for the stop bit. The data line transitions from idle. Okay, gotcha. And the receiver detects this stop bit. Okay, that makes sense. The sample. The receiver doesn't continuously monitor the line. Instead, it waits a specific amount of time ideally aiming for the middle of each bit is expected to be stable, and then takes a snapshot of the line's voltage level. What? What? The receiver doesn't continuously monitor the line. It waits a specific amount of time, ideally when the voltage is at the middle. Oh no, ideally aiming for the middle of when each bit is expected to be stable, and then takes a snapshot or sample of the line's voltage. How does it do that? What or how? What do you mean by taking snapshot? Because that was my question. Just use a different word. Oh, no. I know what a snapshot means. And on a photograph, how does it translate? Circuitry looks at the voltage level of the data line at one specific moment in time. Okay, fair enough. I think that makes sense. It's pretty cool, to be fair. Like, all this is going on like fucking light speed. Cool. The point of synchronization is managed by having the same baud rate on both devices. Failure to do so may affect the timing of sending and receiving data and can cause discrepancies. It's a mouthful. The allowed difference of baud rate is up to 10% before the timing of bits gets too far off. Okay, so it just has to be within 10%. Thing pretty good. Okay, data transmission. Wonder if it's like 10% because it's like so fast to read data. I think this is my guess. I've seen it somewhere. Don't know where. I think this is the baud rate. Okay, data transmission. Parity bits, stop bits. Okay, so there's a start, stop, data, and something in between. In UART, the mode of transmission is in the form of a packet. The piece that connects the transmitter and the UART and in UART, the mode of transmission is in the form of a packet. The piece that connects the transmitter and receiver includes the creation of serial packets and controls those physical hardware lines. Damn. Piece that connects the transmitter and the receiver includes the creation of serial packets and controls those physical hardware lines. Packet consists of a stub bit data frame. So you send about a byte in each frame and stub bits. Okay. Says 1. How much can you send maximum? Send about 9, 10, 12, and 13. It's a weird number. Okay. The UART data transmission. Excuse me. it stable? I mean, it doesn't say it does. It's not unstable. Okay. The UART data transmission line is normally held at a high voltage level when it's not transmitting data. To start the transfer of data, the transmitting UART pulls the transmission line from high to low. Yep. And the receiving UART detects high to low voltage transition, begins reading the bits in the data frame at the frequency of baud rate. So that means stop bit is 0. Is it? I mean, I would guess high to low. Because if it's always high, yeah. I think. The UART data transmission line is normally held at a high voltage level when it's not transmitting data. Okay, yeah. To start the transfer of data, the transmitting UART pulls the transmission line from high to low for 1 clock cycle. When the receiving UART detects this change in voltage, it starts reading the data frame. So this is like the trigger for the rest of it. Okay, and I'm guessing here stop bit might go from 0 to 1. Okay. Things are making sense. Yeah, I think so. Yeah. The data frame contains the actual data being transferred. It can be 5 bits up to 8 bits long if a parity bit is used. Okay, so it can be a byte if you use a parity bit. The data is sent with the least significant bit first. Data is sent with least significant bit first. Okay. So it's the same, doesn't use the network endian. Least significant bit first. Yeah. Okay. Then again, I'm guessing the receiver would read it, so I don't need to worry about it. Something to keep in mind. Parity. New word. Okay. Parity describes the evenness or oddness of a number. Okay. Parity bit is a way for the receiving UART to tell if any data has changed during transmission. Bits can be changed by electromagnetic radiation, mismatched baud rates, or long distance data transfers. Okay. Interesting. After the receiving UART reads the data frame, it counts the number of bits with a value of 1 and checks if the total is an even or odd number. If the parity bit is a 0, even parity, the 1 or logic high bit in the data frame. Okay, yeah, that's pretty cool. So if the parity is 0, the number of ones has to be even. Should be a total of an even number. And okay, that makes sense. Even and odd parity. And if the parity bit is 1, would you... interesting. Thinking, how would I count the bits? I guess could do an AND. Let's say if I send a byte, there's 8 ones. No, can't do an AND. Well, to be fair, if it would mean the number is even, not necessarily. Because if the last 0 is 1, sorry, the last bit is 1. Okay, but I think it's possible. I think you can do some bit magic to figure that out. When the parity bit matches the data, the UART knows that the transmission was free of errors. But if the parity bit is 0 and the total is odd, Hang on, did I read it wrong? Ah, okay. Easy. I did read it wrong. Okay. So if you send 0, that means you're sending an even number. Okay. Easy. But if the parity bit is 0 and the total is odd, or the parity is 1, and UART knows that the bits in the data frame have changed. So what do you do in that situation? Resend it? Oh, yeah, because you get a response. Is it for each bit or each data frame? That's a lot of acknowledgement. So if it's an error, you got to resend the previous one. Guessing. Okay. Stop bits. To signal the end of the data packet, sending UART drives the data transmission line from low to high. I guess that bit. Oh, okay. So it will be 1 1 or 1 at the end. Okay. That's pretty cool. It's quite interesting. Learned something new. Steps of UART transmission. Yes. First, receives data in parallel from the data bus. So this would be Pico. So you send some data, transmitting UART. To be fair, it can be from the other side too. So you get a 0, so that's the start bit. Actually, the question then becomes, because the data frame can be 5 to 9, how do you know which one's the parity and which one's the stop bit? It's about 1, 2, 3, 4, 5. I have to say, to me, this is like magic. Yeah, so cool. Like, there's so much going on. It's awesome. We haven't even got to the Wi-Fi part yet. They're like 3 layers below. Oh, I mean, that was my goal anyways, to understand something new, and I'm getting what I asked for. Yeah, this is cool. Honestly, I'm loving this. Second, the transmitting UART adds the stop bit, parity bit, and the stop bit to the data frame. Yeah. So this is a data frame. Ah. 1, 2, 3, 4, 5, 6, 7. Stop bit 0, 1. What are these pins? 1, 2, 3, 4, 5, 6, 7, 8, 9. One, no. I guess I just need to send the stop bit. Hang on, no. Okay, I just got it. So all I need to do is send the data. The device adds the start and stop parity and stop bit. Okay. I mean, that makes it a lot more easier. Oops. This is like some great documentation. Whoever wrote this? By Eric Pena and Mary Grace. The last name is a bit hard, but great documentation. So clear. Amazing. And the language is quite simple too. It helps simple folks like myself. Okay, so step 2 is adding the stop bit, parity, and the stop bit. And third, the entire packet is sent serially, starting from stop bit to stop bit. It's funny to say them together. Stop bit, stop bit, stop bit, stop bit. Okay, serially starting from start bit to stop bit, from the transmitting UART to the receiving UART. The receiving UART samples the data line at the pre-configured baud rate. Yeah, because it will. So I guess it's up to me to use the same baud rate as the receiver. So that means the people who wrote the software for the ESP, like, yeah. Okay. And there's a fourth step. The receiving UART discards the stop bit, parity bit, and the stop bit from the data frame. Okay, I think I get it. So I guess how it works is you send a certain amount of data. There's a maximum. And it just discards the stuff that it doesn't need. The receiving UART converts the serial data back into parallel and transfers it to the data bus on the receiving end. Then you send it back. And it's in the same order. Yeah. Okay. That makes sense too. Frame protocol. Mosquito. It's just one today. I murdered all of them last week. About 20 mosquitoes in here. Trained a bit a few days ago, so I'm guessing that's where it's from. Okay, the frame protocol. Cold. Oh, okay. Yeah, oh, I thought I was done. I mean, it's nearly there. Just got a little bit more. Okay, I'll finish this today. One key feature that is available in UART, yet not fully used, is the implementation of a frame protocol. The main use and importance of this is an added value for security and protection on each device. For instance, when two devices use the same UART frame protocol, there are tendencies that when connecting to the same UART without checking the configuration, the device will be connected to different pins that cause malfunction in the system. When two devices use the same UART frame protocol, there are tendencies. Okay, so if you don't check the configuration, the pins might not be connected. Okay. Sort of get it, not really. Okay. On the other hand, implementing this ensures security because of the need to pass the information received in alignment with the design frame protocol. Each frame protocol is specifically designed to be unique and secure. Almost had it. Fuck. It's got a friend. Fucking two of them now. Fuck me. Okay. Gonna ignore the problem. It's not that easy. These motherfuckers fly right in your face. Fuck off. Okay. Where was I? Yep, yeah. On the other hand, implementing this ensures security because of the need to parse the information received in alignment with the design frame protocol. Each frame protocol is specifically designed to be unique and secure. That's a lot of frame protocols. Designing a frame protocol, designers can set the desired headers, trailers, including CRC, to different devices. In figure 13, 2 bytes. Why did I read it like that? Because of the bracket. 2 bytes are set as part of the header. Damn. Isn't there like just 9 bits in here? You set 2 headers, you set a command, you set a data length. It's like 4 bits gone. Like half your payload. Unless you can send a lot more. Maybe you can. Well, they forgot to add a version. Just saying. They're not even flying that fast. Okay, I got one. Still another one on the loose. You know, it's more than one. No, I didn't get that one. Warming up my knuckles. Okay. Attempt 3 at ignoring the mosquito. Okay. I mean, I would add a version to this. Header 1, header 2. Okay, well, one of these could be. Okay, no, I'm okay. Attempt 3 at ignoring the mosquito. Based on the sample, you can set a header, trailer, and what is CRC? Oh, okay. Cyclic redundancy check-in that are unique to your device. To be fair, won't this be set by... Excuse me? Won't this be set by the ESP? Good question. I wonder if it's already set. What's a cyclic redundancy check-in? No clue. To be honest, this mosquito is like fucking annoying me. Okay. Attempt 4. Header 1. H1 is that. Some hex And the whole room's empty. Does it have to fly in my face? Okay. Header 1. Hang on. Gotta like save this. Say UART. And yeah. Read chapter 11 of this. Oh, sorry. Bring it back. This doc. Okay. I think I don't need this here. Fuck. Not there. Here. Oh, it's raining. Cool. I like the rain. UART is the way forward. We focus on chapter 11. Let's say one more. UART intro. Oops. And then P266 technical reference. What the fuck? Okay. 80. Ah, motherfucker. Copied it to the wrong place. I blame the mosquito. Blame the mosquito. Fucking hell. But it would. Okay, never mind. AT commands. Don't know what that is yet, but I know it's relevant. Okay. Okay, save. Done. Okay. I want to finish this in this stream. Okay. So I'm guessing the ESP has headers that specify the help me recognize if it's the right device. Okay. Command selection. Okay. Kind of like the display. You send a command, then the command. That didn't make any sense. Fuck it. Kind of like the display. We'll leave it at that. Data length per command. So this is the n. N to n plus 1. What? Okay, it'll make sense. Keep reading. Data length will be based on the command chosen. You can maximize the length of data depending on the command chosen. So it can vary based on the selection. In that case, the data length can be adjusted. Data n varying data. Data is the payload to be transferred from devices. Excuse me. Data is the payload to be transferred from devices. Right. Yeah. Okay, you just specify n here. Trailer. Okay, I got it. T1 is this, T2 is that. Trailers are data that are added after transmission is ended. Just like the header, they can be uniquely identified. Yeah, what is this? The that redundancy checking formula is an added error detecting mode to detect accidental changes to the raw data. The CRC value of the transmitting device must always be equal to the CRC computations on the receiver's end. Right, okay. It is advisable to add security by implementing frame protocols for each UART device. Frame protocol needs identical configuration, on both devices. Yeah, makes sense. UART operations. When using any hardware communication protocol, it is a prerequisite to check the datasheet and hardware reference manual. Yes, sir. Here are the steps to follow. Okay, beautiful. Check the datasheet interface of the device. Datasheet interface of the device. Okay. Yeah. Where's the second? Lost. Check the specific details for the UART port, such as the details for UART port, such as operation mode, data bits length, the parity bit, stop bits, sample UART port details in datasheet. UART port. Okay. We'll just add this to do. Not sure how yet, but okay. A reminder to self. The sample MCU. What's an MCU? Provide a full, that thing, whatever that is. No, there were like 3 mosquitoes before. Caught 2, and there's now 4. Back with a vengeance. Okay, sample MCUs provide a full duplex UART port. Memory map. What is this? Beeper. I like the beeper. Microcontroller memory map. Guessing this is just an example. Does this, oops, too much zoom. Let's go here. No, hang on, can just check the index. Chapter E11, UART. Okay. They did say check the interface. Brilliant. I'm guessing it's the same. Here. Okay. There's two interfaces. Damn. Which one? Okay. Is that a similar? Inverting. Parity bit, data bit, stop bit. Okay. The baud rate. I knew it. Oh, okay. But which one do I have to specify? Damn. It's quite, if you can see the mosquito. Okay. It's like quite high. Crazy. Inverting. Q. Oh, there's a Q. Loop back. Line stop. Flow control. Transmit queue. Receiving queue. Interrupt. Interface. Interrupt cycle. Send empty. FIFO interrupt. Error detection. Ooh, okay. Get a parity error. Termination line error. UART Berk det insta. Receive the frame error. Received frame error. Okay. Flow control status interrupt. Example of interrupt handler process. Damn, so much comment. UART interrupt status. While status is not 0. If it's frame error, write something UART didn't clear. Okay. Okay, I don't see any. What's the PWM? Okay, let's not get totally lost. Best not to scroll beyond chapter 11. Right. Okay. There's a lot of information here. Okay, got it. I didn't see this though. Memory map. Okay. Data bits length, the parity bit. Okay. UART port. Does it have a UART port? Not really, but we'll figure it out. Okay, sorry. Details for the UART port, such as operation mode, data bits, the parity bit, stop bits. I did see these. Sample UART port details in datasheet. I think I saw this. Yeah. I did. Don't need this. Nah. Here, go back to 11. Introduction. No, this was the pin. There's no address. Okay. Well, I mean, I'll figure it out. No worries. The sample MCUs provide a full duplex UART port, which is fully compatible with PC standard UARTs. The UART port provides a simplified UART interface to other peripherals or hosts, supporting full duplex DMA and a synchronous transfer of serial data. UART port includes support for 5 to 8 data bits and none, even, or odd parity. A frame is terminated by 1.5 or 2 stop bits. I think this is handled by the device. So, fourth, check the UART operation details, including the baud rate computation. Okay, so I can configure it. Baud rate is configured by using the following sample formula. Formula varies depending on the microcontroller. Sample details of UART operation: 5 to 8 bits, 1, 2, or 1.5 stop bits. Yeah, none or even or odd parity. Programmable oversample rate 4, 8, 16, and 32. And baud rate is PCLK divided by, it looks like a very small number, unless PCLK is huge. What is PCLK? Some kind of clock? Oh, hang on. Maybe this scares them off. Okay. Where? OSR is the oversample rate. Okay. Excuse me. UART LCR dot OSR. Where is that? Equals 0 to 3. Any of this mentioned here? Mosquito. Fuck off. Well, after the stream, I'm gonna get my mosquito bat. Fucking murder a few more mosquitoes. And there's like 4 of them here. What's a TTL converter? Don't think it's necessary. Baud rate of this period print contents is related to using 40M crystal. The section thing, it is 40. It's like really tiny though. Can't read it. I'd have to take a picture, then zoom in. Okay. Section print baud rate is that. And use 26M. The baud rate is that. Okay. So I'll have to have a look at the crystal. Okay. All right. Okay. I think the baud rate, not a big deal. UART div. Okay, is that M? Oh, okay. Is this? What about PCLK? Oh, I think this might be big or small because it's M plus that. No, it is quite big. Depends on oversample rate. Or yeah, baud rate divider. Okay. N div M fractional baud rate M. UART blah blah blah, that much. For the baud rate, make sure to check what peripheral clock to use. Okay. Oh, okay. So, oops. So that's what this means. So based on one of these, so that's the clock cycle. Okay, makes sense. Okay. Okay, these things vary per device. Okay. Baud rate based on 26 megahertz. And it's 600 or that much, which is because the rest of the variables are different variables. Baud rate sample. Okay, it's fine. Next part is to check the detail registers for UART configuration. Take a look at the parameter in computing the baud rate, such as you see UART that, UART that, and UART that. Table 4 will lead to specific register to cover. Baud rate divider. Okay. Under each register, check the details and substitute the values to compute for the baud rate. Then start implementing the UART. Okay. Why is it important? Why? Familiarity with the UART communication protocol is advantageous when developing robust quality-driven products. Knowing how to send data using only 2 wires as well as how to transport a whole pack of data or payload will help to ensure that data is transferred and received without error. Since UART is the most commonly used hardware communication protocol, this knowledge can enable design flexibility in future designs. Okay. It's not a very complicated protocol so far. So you can use it for debugging, manufacturing that, customer or client updates, testing / verification. Okay, these are some references. Well, one thing that slightly worries me doesn't say you can use it for communication. I suppose okay. I suppose it's like a form of debugging. It's not debugging, but you are just reading from another device. You're reading data from another device. Okay. Okay. That was really good. I think I feel a lot more confident after today. Because before I started the stream, I was like, fuck. I have no idea what to do. But now I have some idea. Like there is a direction. And yeah, thanks to the authors. That was really good documentation. Still haven't written a line of code. But it's fine. I'm not too concerned. I feel like I can do this now. Getting somewhere. Yeah. Just gotta figure out some of these things. And things should be good to go. Don't know if we'll be writing any code tomorrow. But I feel like it's not too far. Okay, I think that's pretty much it for today. There is a lot of reading. New work on embedded stuff. Surprised how much. To be fair, everything is a side quest because I don't know anything. Well, yeah. In terms of embedded stuff. Yeah, but I guess that was good. I quite liked today. It's quite fun to make some progress. Okay, I guess that's it. If you're watching, enjoy the rest of your Sunday or Saturday, depending where you are. And hope you have a good weekend. I shall see you tomorrow. Yeah. See ya.